Hi, this is Swati, and in today's video we'll see the complete concept on circles, all the theorems, all the important points in just one video. So I'm very sure from this video you will be very confident in the chapter circles. Now let's get started. So first, I'm sure you all know what a circle is, but before that I will just explain you all the parts of a circle which you are already aware of, but just let's revise it. So center, what is the center of the circle? Center of the circle is right here in the center, and this is the center of the circle. So from this center point, all the lines are equidistant from the center. All these lines are at equal distance. Now next is the radius. Radius is the line drawn from the center to anywhere on this circle to the boundary. So this is a radius, this is a radius, this is a radius. All these are radius. So it is a line from the center to anywhere on the circumference of the circle. Now next is the diameter. Diameter is a line segment which passes through the center. So now this is the diameter. It passes through the center, having the two endpoints on the circumference of the circle. So this is the diameter. Now the relation between radius and diameter, we know that this part is radius, this part is radius. So I can write the diameter is r plus r, which is 2r. So diameter is 2r, and on the other hand I can write that radius is half of the diameter. Next is a chord. Chord is again a line segment whose end points are on the circumference of the circle. Now here I can say that this is my chord AB, so whose end points are on the circumference. Now circumference is basically the boundary, this the outer boundary. The boundary is known as the circumference. It's like the perimeter. Arc is the portion of a circle, small portion. So now if I consider this is known as the arc. It is nothing but a portion of a circle. Sector is, now let me just join this one. Okay, sector is this yellow region that I'm drawing. So this is a sector. So basically sector is formed between the two radii and an arc of a circle. Now this portion is the sector of the circle. Now since this is smaller, so it is minor sector, and the remaining portion is known as the major sector. Now segment on the other hand is, it is a region between a chord and an arc. So we can consider this as a segment. This is a segment. It is the region between a chord and an arc, whereas sector is the region between two radii and an arc. I'm sure you're aware of all of these basic terms. Now let's go to the theorems. Now first theorem, equal chords of a circle subtend equal angles at the center. Now it is given equal chords. So the chords are equal. The chords are equal. Equal chords subtend equal angles at the center. So if AB is equal to CD, therefore the angles that they subtend at the center, that is this angle and this angle, they become equal. So therefore angle AOB will be equal to angle COT. Next, theorem 9.2. If the angles subtended by the chords of a circle at the center are equal. Now here the angles that they subtend at the center. Now this is the angle by a chord that is subtending at the center, and this is another. So if these center angles are equal, then the chords are equal. So it is given that if angle AOB and angle COD are equal, therefore the chords will be equal. These are just vice versa. Next one, 9.3. The perpendicular drawn from the center of a circle to a chord bisects the chord. So the perpendicular that is drawn from the center, this is the center, to the chord is AB. So when you drop a perpendicular to the chord, that means if OX is perpendicular to AB, then the chord is bisected. Then this chord AB is divided into two equal halves. So AX will be equal to XB. AX will be equal to XB. Now next one. The line drawn through the center of the circle to bisect a chord is perpendicular to chord. So now you can see a line is drawn OX on the chord. So a line drawn through the center of a circle to bisect a chord. The chord is being bisected. So if the chord is being bisected, that means a chord is divided into two halves, then the line that is drawn is definitely perpendicular to the chord. So therefore OX is perpendicular to AB. So these are all vice versas. Next, equal chords of a circle. So let us name the chords. This is chord AB, chord CD, and this is my center O. Equal chords of a circle. So these two chords are equal given. So equal chords of a circle are equidistant. Equidistant means equal distance. It is at equal distance from the center. So this is my center. So if the chords are equal, they are at equal distance from the center. Therefore, OA will be equal to OD. The distance from the center to the chord will be equal. And now again the vice versa. This is chord AB, this is chord CD, and this is the center. Chords equidistant from the center. So the chords that are equidistant from the center, that means these two distances are equal. So if they are equidistant from the center, then the chords will be equal to each other. The A4 AB will be equal to CD. Now moving on. Now till now the theorems were very easy. Now from here you have a very important, set of theorems that are new to you. Angle subtended by an arc of a circle. Now let me draw a chord. Now this is my chord AB, right? Now using this chord I can construct many angles, right? So see, this is one angle that is formed using the chord. This is another angle that is formed using the chord, isn't it? So similarly, I can get so many angles by an arc of a circle. So let me show it to you. Now suppose this is my center of a circle. Using the arc of a circle, an angle is formed. Similarly, using the same arc, another angle is formed. Using the same arc, another angle is formed, right? So you can form multiple angles by an arc of a circle. Now next theorem is about this. Let us read. The angle subtended by an arc at the center. So see, let me just name them A, B, C, D, and this is my center of the circle. The angle subtended by an arc is AB, and this is the angle subtended at the center, is double the angle subtended by it at any point on the remaining part of the circle. So on the remaining part of the circle means this blue portion. So on this blue portion, whatever angles are formed, here we have angle C, angle D. So if they are, let us take they are X, then the center angle is double of them. The center angle becomes 2x. It's a very important theorem that the center angle is always the double of the angle subtended by the remaining part of the circle. So let's say if x is equal to 60 degrees, then the center angle, that is 2x, will be 2 into 60, which is 120 degrees. I hope this is clear. We have so many questions using these theorems, and I'm very sure that if you are good at the theorems, you can easily crack all the questions. Now the next one, angle in a semicircle is 90. What is a semicircle? So this is my diameter AB. The diameter divides the circle into two equal parts. So each part is known as the semicircle. So the angle that is formed in semicircle is always 90. Very useful, very important. It will be used in almost all the questions. So see, this is one angle formed in this semicircle. This is 90 degrees. Similarly, there's another angle formed in another semicircle. This is again 90 degrees. Okay, next one, angle in the same segment of a circle are equal. So what is a segment? We have discussed that it is the region bounded between an arc and a chord. So now see, this is my segment. This is one segment. This is minor segment. And the remaining portion here is, the remaining portion this is major segment, right? This is major segment. Blue is minor, red is major. So angle in the same segment of a circle. Now using this segment, this chord, we have two angles forming in this major segment. So they both are equal. So if this is x, this is also going to be x. I hope this is clear. Now next one, if a line segment joining two points subtend equal angles. So let me take 2 points. If a line segment joining 2 points subtend equal angles at two another points lying on the same side of the line. So containing the line segment, now containing this line segment, we are getting two more angles, isn't it? See, if a line segment joining 2 points AB subtend equal angles at two other points lying on the same side. These are the two other points, they are lying on the same side of the line containing the line segment. These angles are formed using these line segment. So these are two equal angles. Then the 4 points on the circle, they are known as concyclic. Now these 4 points lie on a circle. So if the 4 points lie on a circle, then they are known as concyclic. Concyclic means lying inside the circle. Now, based on this, you have very important cyclic quadrilateral. A quadrilateral having four sides. Now, what is cyclic? A quadrilateral is called cyclic if all four vertices of it lie on the circle. So, as we know that quadrilateral has four vertices. So, if all the four vertices are on the circle, then that quadrilateral is known as a cyclic quadrilateral. Now see, these are my four vertices A, B, C, D. I see that all my four vertices lie on the circle. So therefore ABCD is a cyclic quadrilateral. Cyclic quadrilateral, since they are lying it on the same circle. Now next, very important theorems on cyclic quadrilateral. If the sum of a pair of opposite angles of a quadrilateral is 180 degrees. Now let me draw a cyclic quadrilateral here. You know that cyclic quadrilateral has all 4 points on the circle. So what does the theorem state? If the sum of a pair of opposite angles A and C, if the sum of them is 180 degree, similarly B and D are also opposite to each other. If the sum is 180, then the quadrilateral is cyclic. So if in any question you prove that the opposite angles are supplementary, the measure of them is 180, the sum of them is 180, then the quadrilateral is a cyclic quadrilateral. This is one thing. And also, if all the 4 points lie on the circle, it is again a cyclic quadrilateral. I hope all these theorems are clear. If you are clear with all the theorems, I'm very sure that you will be able to solve all the questions of circle. So wait and watch my next video where I will be sharing 10 most important and most repeated questions of this chapter, which is a mixture of both R.D. Sharma and R.S. Agarwal. See you in my next video. Thank you.